In this video, we will cover the calculation of the correlation coefficient. First, we see how to compute the correlation coefficient from n data pairs. The data pairs consist of both an x component and a y component, and we will assume that we have n of them. As you should recall from basic math, this uppercase Greek letter sigma denotes summation. Therefore, sigma x denotes the sum of x, which is all of the x values summed up. Similarly, the sum of y is all of the y values summed up. Then the sum of x squared is the sum of all the squares of x. And then we have the sum of y squared. And lastly, the sum of xy, which is the sum of each x multiplied by each corresponding y. From these sums, what we'll do is we'll calculate what's called the sum of squares. The first equation states SS underscore x, which is called the sum of squares of x. From the equation, we see that it is the sum of the x's squared minus the sum of x quantity squared divided by n. The sum of squares of y is very similar, except it is the sum of y squared minus the sum of y quantity squared divided by n. The sum of squares of xy is the sum of x times y minus the sum of x times the sum of y divided by n. Once you have calculated each of the sum of squares, you can calculate the correlation coefficient value using the equation at the bottom of the screen. One thing to note is that the equation for SSX is actually just the numerator of the variance. So SSX is the sum of x minus x bar quantity squared, and that value is equivalent to the value I presented to you on the previous slide. Those two ways of finding the sum of squares of x are actually mathematically equivalent as shown here. We also see that the sum of squares of y and the sum of squares of xy have corresponding mathematically equivalent equations as shown here. So let's do an example. Here we have a cold call example. Jordan manages retirement accounts for Enright Associates. She makes X calls in a day, and Y is the corresponding sales she makes. So we have the values of X and Y listed here. Let's create a scatter plot for the data, and let's find the correlation coefficient. If you've never plotted a scatter plot, I definitely encourage you to do that. In order to do that, you can simply print out some graph paper or even just print out this slide. And then what you do is you just take each point and plot it. For example, we have a point where x is 5 and y is 4. That is the first point on the left. Then you can continue plotting all of the points from each data pair. And then one important thing to note is that I place labels on the x and y axes. Also, I gave this scatter plot a title. In fact, labeling your graph is very important. You want to have an attractive graph, and part of making an attractive graph is labeling your axes and giving it a proper title. So I went ahead and put this into table format to make it look easier. Okay, so I put the data into a table format. So we see that we have the data pairs x, y. If we take x and square it when x equals 12, we would get 144. If y is 10, y squared would be 100. And x times y, in this case, would be 120, as shown here. Those calculations come from the first data pair. Then you can do those calculations for every single data pair, and then you'll want to sum each column. So I'll put the sums at the bottom of the table. And now we can calculate the sum of squares of x. So the sum of x squared is 1407, and the sum of x is 83, and n is 6. Why is n 6? Because we have 6 data pairs. And this value of the sum of squares of x can be easily calculated with a standard calculator, and we should get 258.83. Doing a similar operation for the sum of squares y, we plug in 1014, and then we subtract 7 squared, 70 squared, and divide by n, which is 6. And we get 197.33. Lastly, we do the sum of squares of xy. Sum of squares of xy, we plug in 1193 minus 83 times 7d divided by 6, and we get 224.67. And then we can plug all those sum of squares of x into the equation and get the value of r to be 0.994. This calculation can be done using any calculator, but of course, there are other ways to do it. Programs such as R, Excel, or Python can do this calculation for you also. In this case, we only have 6 data pairs, so it's not that difficult of a calculation. We can do it by hand. So I leave you with this cartoon, and I'll see you in the next video.